Today we will present about a rare natural phenomenon bringing silver dust to Australia. Climate change is making it more common. Hello, my name is Norapat Mungnimit. My nickname is Pat.
My name is Phonyathat Thipsorn. My nickname Phil.
And today we have a video. Let's watch the video.
Australia's highly variable climate is influenced by the broad patterns in the oceans around it and the atmosphere above it. We call these patterns our climate drivers. The most significant climate driver in the Indian Ocean is the Indian Ocean Dipole, often called the IOD. The IOD refers to the year-to-year changes of tropical sea temperatures in the western and eastern Indian Ocean. These changes can alter the weather patterns that affect Australia's rainfall. The IOD varies between three phases: positive, neutral, and negative. On average, each phase occurs about every 3 to 5 years. Positive or negative IOD phases usually begin in autumn or winter and return to neutral around the end of spring when the northern Australian monsoon arrives. During a neutral phase, water from the Pacific flows between the islands of Indonesia, keeping seas to Australia's northwest warm. Air rises above this area and falls over the western half of the basin, blowing westerly winds along the equator. Temperatures are close to normal across the tropical Indian Ocean, and the IOD has little influence on our climate. During a negative phase, westerly winds intensify, allowing warmer waters to concentrate near Australia. These stronger winds also mean it's harder for cool water to rise up from the deep near Indonesia. As these warmer waters move east, the clouds follow, favouring weather patterns that ultimately bring rain to southern Australia. A positive IOD phase has the reverse temperature pattern in the Indian Ocean and the opposite effect on Australia's climate. The westerly winds weaken and sometimes easterly winds form, allowing warm water to shift towards Africa. South of Indonesia, these changes in the winds allow cool water to rise up from the ocean depths. With cooler waters and descending air in the eastern Indian Ocean, less cloud forms. This changes the path of weather systems coming from Australia's west, often meaning less rain over central and southeast areas. Often, but not always, a positive IOD coincides with the drying influence of the El Niño in the Pacific, both drawing rainfall away from Australia. For Southeast Australia, this can cause the failure of critical winter-spring rains and prime the land for severe summer fire seasons. For instance, 1982, the driest year on record for the region, was both a positive IOD and El Niño, and was followed by the devastating Ash Wednesday bushfires. Likewise, a negative IOD can often occur during La Niña, both pushing more rain toward Australia. If both are strong, Australia can experience significant rainfall and widespread flooding. We saw this in 2 of the 3 wettest years on record for Australia, 1974 and 2010. Both years brought costly and deadly flooding to many areas. The Indian Ocean Dipole plays an important role in driving Australia's climate. No 2 Indian Ocean Dipole events and no 2 set of impacts are exactly the same. Understanding this key Australian climate driver can help you make smarter decisions.
A rare natural phenomenon brings silver dust to Australia. Fire spread through much of Southeast Australia, fueled by dry vegetation from the ongoing and finished by hot, windy fire weather. On the outer side of the Indian Ocean, torrential rainfall and flooding devastate parts of Eastern Africa. Communities there now face a local plague and food shortage. The Indian Ocean Dipole refers to the difference in sea surface temperature on either side of the Indian Ocean, which alter rainfall patterns in Australia and other nations in the region. Climate drivers. such as the Indian Ocean Dipole, are an entirely natural phenomenon, but climate change is modifying the behavior of these climate modes. In research published today in Nature, we reconstructed Indian Ocean Dipole variability over the last millennium. We found extreme positive Indian Ocean Dipole events like last year are historically very rare. The Indian Ocean Dipole had a positive phase and negative phase. Positive phase, the outside water temperature is lower than normal and west side water temperature is higher than normal. The signature of extreme events like past positive Indian Ocean Dipole is whitened in the coral skeleton. Altogether, our coral-based reconstruction of the Indian Ocean Dipole spans 500 years between 2014 and 2019. There are gaps in the timeline, but we have the best picture so far of how exactly the Indian Ocean Dipole has varied in the past. To uncover just how the Indian Ocean Dipole has changed, we look back to the last millennium using natural record collates taken from 9 coral skeletons. Specimen of coral collected from Sumatra, Indonesia. It's good to know the different causing of the positive Indian Ocean Dipole events. Coral growth are not like trees. For every year they live, they produce a growth band. An individual coral can live for more than 100 years. Maturing the oxygen in this growth band gives us a detailed history of the water temperature the coral grew in and the amount of rainfall over the reef. The signature of extreme events like past positive Indian Ocean Dipole is whitened in the coral skeleton. Altogether, our coral-based reconstruction of the Indian Ocean Dipole spans 500 years between 2014 and 2019. There are gaps in the timeline, but we have the best picture so far of how exactly the Indian Ocean Dipole has varied in the past.
Indian Ocean Dipole events have been rare in the past. We have seen the severe positive Indian Ocean Dipole 10 times, 4 times in 60 years, and 6 times in 440 years before. Markets it clear that more and more violet is occurring. Events like 2019 are not the worst of what the Indian Ocean Dipole can throw at us. Discovering that in the years 2019, the Indian Ocean Dipole event is not the worst. In 1675, the Indian Ocean Dipole event was considered the worst in the past 60 years. The 1675 event was around 40% stronger from the event of the year 1675. Severe drought causing famine, death, and causing war, showing that the severe fluctuation in the Indian Ocean are caused by humans. Indian Ocean dipole continue to bring storm weather to our region. Climate change caused by humans and the weather makes the ocean in the west of the Indian Ocean warmer than in the east. Positive Indian Ocean dipole events occur frequently because the water is still warm. The simulation can predict that positive Indian Ocean dipole events will occur more often if there is still a continual greenhouse gas emissions. Water simulation will be released shortly, and data from the fossil collect study shows that it's possible. We have not seen the worst of the Indian Ocean dipole, so we plan to deal with future water conditions. The Indian Ocean will have a long-term effect on global warming, directly affecting Australia. The most important is the huge greenhouse gas emissions will make the positive Indian Ocean dipole event worse and worse in the future. End of the presentation. Thank you very much for watching. Thank you. Goodbye.